Should we... Are we able to turn the lights off just here?
I don't believe so. As far as I could tell, the light switch was literally just you could swap the theme to light mode.
I have to turn off all my lights in one of my shoot rooms because it's just so awful with projector. Alright. Cool. So do you see everything?
Yep.
That's what I was thinking.
No, the switch at the back literally has on and off.
Well, let's see what happens here. It's like a movie now.
I would just swap VS Code to light theme and let the haters.
Oh, okay, which one are we going to use?
White light.
White light.
Does the audience have any suggestions for
Any-
a light
any
theme for
preferences?
VS Code? Personally, I'm partial to Light Plus, but...
Light plus, let's do it. Oh,
Oh yeah, there we go.
there you go.
That's good stuff.
Up everyone.
To see what it looks like. Hello. Yeah, that was good. Cool. Am I getting flamed on stream?
Yeah, you're getting killed with dark. No, come on, that doesn't just feel passive.
Do I need to monitor chat?
Maybe best if you stay,
you
Sasha.
don't. Okay.
Yeah, we're good.
All right. We're going to go with light mode for just this hour. You can do it. You can live through it. I promise.
I don't think I can.
Because you can't see in the room otherwise if we go to dark mode. Can we? Could you see the screen when it was in dark mode? No, you can't. I was sitting at the back. You can't see it. So we're returning back to the 90s. All right.
All right, we ready to get started?
Yeah.
Yep. Cool. All right. Hello, everyone on stream and in person. So today we're doing the Assignment 1 live stream. All good? Yeah, cool. So first things first, to get to Assignment 1, just go to the homepage as normal. You can scroll down and there should be Assignment 1 down there. You can also click up here and you should have Assignment 1. So either way is perfectly fine. You go there and we basically have your first assignment for the term. So this is quite a large assignment. I recommend just reading through everything like maybe once or twice until you get a good understanding before starting. But basically, let's get started. So assignment 1 is going to be called CS Defense. Basically, it's inspired by a lot of tower defense games. So I don't know if any of you guys are familiar with Bloons Tower Defense, but that's what it's most inspired by. Quickly, if you want to have a look at what it looks like, there's a link to Bloons Tower Defense down here. Close that. And you can play this if you want. And of course, we're getting an ad. Just, yeah, we'll wait for that to go through. But yeah, if you're ever confused about something in the assignment, it is like based off of this a lot. So you can always go here if you're confused. But obviously, there's other ways you can figure it out. Cool. I might turn that down. Have that load up. Cool. So I think this game was released in like 2007, so it's quite a long time ago. But basically, this is what it is. So what you do is you start a new game, and you basically have just an entire map here. It's got a path, it's got a bunch of grass around it. And what you can do is place down towers. So in this game, all the towers are basically monkeys, for whatever reason. So you can place all those down, and what they'll do is you can click Start Round, and some enemies will spawn in the form of balloons, and then your monkeys basically go and attack them. So this is the basis of what you'll be implementing in the assignment. We won't have rounds in the assignment, but basically just enemies coming through on a path, towers that can destroy them, and just all of that. So yeah, feel free to play around with all this stuff. I'll go through a couple more rounds just to show off some other things. So another cool thing is that you can upgrade your monkeys, which I can't do for some reason here. You need to wait till the end of the round. All right, so this is actually intentional to get enemies to come past. But if the towers can't reach the enemies, then they'll just keep going on the path, they won't get attacked. And then once they reach the end, you'll see that your lives go down basically every time. So you'll be implementing a lot of this stuff, everything minus rounds basically, in our own version of this tower defense game. So yeah, you also have upgrading towers, which I wanted to show but can't see it here for some reason. Yeah, does anyone have any questions before we go on? Cool. What are you
You've
laughing
been
at?
trolling in chat.
I've been trolled in chat.
This is intentional.
It was intentional, actually, and you can't prove otherwise. So, in this assignment, you guys will basically be using all the concepts you've learnt up until now. So, 2D arrays, structs, enums, loops, all that kind of stuff. It's all going to come together into one assignment. So I recommend reading through the assignment structure a couple times because it can be a bit confusing. There's a lot of stuff in here. But basically, the main idea behind, this book is coming off, there we go. The main idea behind what this game will be is that you're going to have a 2D array, which is essentially just this entire map, right? So it's got height and width, basically. That's your map. And then inside of our implementation, we have tiles in it. So it's like you have tile at 0, 0 coordinate or a 0, 1 coordinate, a 0, 2 coordinate, all that kind of stuff. And basically, a struct tile is defined here. So a struct tile stores information about the tiles on a map. There's two main things that a tile has. The first one is the type of land it is, and the second one is the type of entity that's basically on top of the land. So we have more in-depth explanations of what each of them are, but your land and your entity are implemented through enums, so we're not using just like integers or arrays or anything like that to do land and entities. We're using enums. So as we know, an enum can basically represent one of a multitude of values. And in this assignment, for example, enum land, it can represent either grass, water, path start, path end, all these other path things, and a teleporter. So you can read through what all these mean. For now, basically just know that grass is what you're going to have as your main your main land, sorry. And like you can kind of look at it in Bloons Tower Defense. That grass is pretty much going to be the same as our kind of grass. You have water as well. A cool thing with water is that you can't place towers on top of them unless they're a special kind of tower, so it like adds more restrictions there. And then all these like path variables is basically just explaining how your path goes from the start to the finish. So once again, if we go back, the path starts here on the left, and then it goes all the way around up to there. So you'll actually be implementing a way to create a path on this 2D array, essentially. So yeah, that's land. Entities are a bit, there's like a lot less to do with them. An entity just like says what is on top of each tile. A lot of the time, it's just going to be empty, so nothing's on top of it. An enemy could be on top of it, however, and then all the kinds of towers that we implement could be on top. So yeah. Moving on from that, there was a mental model here. I don't know what's happened on Chrome, but it's just not working. But if you go on the website, then you should be able to see this mental model. It kind of just shows how entity and land works together on the tile. But another example is just down here. This is what your map's basically going to look like. So all these cubes on the bottom, maybe I'll scroll down a bit more. All these cubes on the bottom is just your land. So the green one is grass, the blue one is water, and then like the brown ones with D, R, U, L, E, all that kind of stuff, that's all your path tiles. So you can kind of see how the path goes from the top left, down, and then around, and then to the end. So yeah. And then you can see that the entities on top, so like this B here is a basic tower. This E is just an enemy, so enemies currently appear on the path, so they can go down like that. And then all these other ones are just different types of towers, so like a power tower here, basic tower here, and a fortified tower here. So yeah. Down to actual implementation for this. So it's great to like be able to visualize it in this like 3D sense, but in terms of how we represent it in our code, it's also important to understand how that works. So the main thing you need to know is that this is the big piece of data that you're going to be manipulating throughout the whole assignment. hopefully it makes some sense what all this is, but it's basically, you've got a 2D array called map. It has map rows, number of rows, and it's got map columns, number of columns. In other words, it's got 6 and 12. That's what we hash define it as in the code. And then each tile in the map is defined by the struct tile that we're looking at earlier. So that's essentially what it is, a 2D array of these struct tiles. I would recommend playing around with this little interactive here. So basically, this is your entire 2D array. It's just got a bunch of struct tiles in it. Hopefully that makes sense. It's just like a grid of struct tiles. You can change all these numbers here. So like map 3, 6, which means go to row 3 and go to column 6, which corresponds to this tile here. So just make sure you know how array indexing works for this assignment. Obviously, I could change this to something else like 4 and 2. And then this is row 4, right, and column 2. So that's how you would index into the array to see different tiles. And then if you actually want to access something in that tile, you need to say dot and then the thing you want to access. So for example, dot land would let you access this part of the tile. I could also change that to dot entity, which lets you access the entity on this tile. And then also enemies. So in this assignment, if there's an enemy on some land, then basically there could be multiple. So this kind of indicates how many there are. So yeah, play around with this, get a good understanding of it before you go ahead. But once you've done that, you can actually get started on the assignment. So a lot of stuff to get through, but it's really important to just understand what you're doing before you start coding. Otherwise, it will get very confusing very quickly. But yeah, so I will follow the instructions on here. I recommend you all do that as well. So make a directory, assignment 1, cd into it, and then just copy this whole command here. So this is the starter code, just like with the labs, how he told you to use the copy command, that just gives you the starter code for the assignment. If I type ls, I see I now have got a file called csdefense, so I can open that up. And this is going to be the starter code. So be warned, there is a lot of it. So there's 178 lines. A lot of it is just stuff to help you out though. So don't stress if like it feels like it's way too much. A lot of it's just like helper functions. So down here we give you some functions to like initialize your map, and this one will print out your map. And then these functions down here also help with printing out the map. So what I recommend is, once again, go through the types at the top. So we defined the enum land type here. It's basically just everything we just went over. So this is everything that a land type could be. Then these are all the things an entity could be as well. And then this is what our struct tile is. So like the big thing that we need to worry about. So that's all the starter code that we give you. We recommend that you write functions in this assignment because we will mark you on style based on functions. So any function prototypes you have, put them here. And these are like some provided prototypes if you need to just remember how they work. And then the actual function definitions I showed you before, just down here. And then you would probably put your own in here as well. That's probably a good place. But yeah. So we give you a main function. It's actually really empty. There's only 2 lines of code in it. We've just given you a lot of like to-dos to kind of push you in the right direction for this assignment. So what we give you right now is we give you that map we were talking about before. We initialize the map. And what this does is that it will initialize the map so that they all have grass land and they have no entity, right? Because it's empty up here. So if we want to do something, we say something like print map. This is another function we give you. And this will print out the entire map. So if I actually go to DCC it now, like so, and then I actually call it, sorry, that makes sense. So this print map function takes in 3 parameters. It takes in the map itself, which is what I provided, but it also takes in the number of lives and the number of money that you have currently. So I forgot about that part, but you always need to provide that when you want to print out the map. So let's say that we've got 100 lives and $500, something like that. Oop, that's all. And let's try to compile that again. Now it's getting annoyed. What's it getting annoyed about? Oh, yes, I put it in the wrong place. Sorry about that. No, that's all right. So this time, should compile. Small issues there, sorry guys. But if we // it now, we'll see it's going to print out the map for us. So the map basically is a 6 by 12 grid. So if we see up here, the hash defined, there should be, map rows, map cols. And basically, when we go to print out the map, it will print out every single tile, essentially. So these dots represent grass tiles, and we know that from just like the initialize map function, that everything should be set to grass, and then entities should be nothing. So everything's just going to be a dot here. We could go ahead, and instead of just printing it out like that, we could instead say something like, okay, maybe I want to change the land at position like row 2, column 2 to be water. I can go ahead and do that. Then if I save that and I recompile it, then we'll see what printing the map actually does. So I do it again, and now we see there's like a tilde here which represents water, basically. So as you change the land and the entity on your map, it will actually change it when you go to print it out. So we've like handled all the printing, like there's a bunch of if statements here for each different type of land, so we don't have to worry about that. But yeah, that's nice there. So along with that, you can also change the entity on a piece of land. So let's say I want to say map for column 8 dot entity. We're going to set that to be just like a basic tower, maybe. Then if we go ahead and we compile that again, we'll see now we've got a basic tower down here. And the important part to note is that it's sitting on top of this piece of grass, basically. So to represent like an entity being on top of a piece of land, we literally just put it on top of the piece of land in the print map function. Cool. And the reason that nothing gets printed earlier is because every entity was set to empty. And if you want, you can go down and look at what happens when the entity is empty. We just print out a bunch of spaces. That's why nothing was printed before. But when we had a tower, we print out this, which is what we got. So yeah, this will let you just represent basically anything on your map using enums. So there's no other types here to represent your map. It's just like the land, the entity, and then maybe if the number of enemies, or if the entity is an enemy, then you can put a number of enemies on it. Cool. So yeah, just make sure you understand the syntax here. We're just saying I want to go to row 2, column 2, and then access that tile, and I want to change the land of that tile to be water. Cool. Moving on. So that's essentially how you would manipulate the map. Moving on, this assignment is split up into 4 stages. So stage 1 and stage 2 basically meant to be like 1-dot exercises you would have in your labs. That's what they're defined by. Stage 3 will be a 2-dot exercise, and stage 4 would be a 3-dot exercise. But everything builds on top of each other, so you want to do stage 1 before you do stage 2, and so on. So this assignment, how it works is it's kind of just, you can think of it as a bunch of labs put together that kind of build off of each other. So currently in labs, you just like write one program for each thing, you submit it, and then you work on the next one. With an assignment, it's kind of like writing the solution for one lab, so like stage 1.1, and then continuing on from that, you write your solution for 1.2 in the same workspace, so in the same code. And that way you'll just kind of build on your program over time as you do each sub-stage, basically. So the important part to do is stage 1, at least. This will show that you've got a good understanding of just being able to use 2D arrays, use structs, and use loops, basically. But stage 1, if you read through it, there's a lot of stuff here. It's basically just getting you to set some stuff up. So first off, we're going to ask you to start, like, print out starting lives, scan in that from the user, print out starting money, scan in that from the user. And then after that, we want to print out, or we want to get the starting point and the ending point from the user. So by now in the labs, you probably should have been able to just like print out a prompt, scan it into a variable, and do that multiple times. That should be okay. And then the hard part of this stage is essentially actually changing the map so that this start point is actually represented on the map. So like, for example, instead of water here, I could have said start point. And maybe we'll copy the same thing here. So let's say at row 1, column 2, we want the start point. And then at row 4, column 10, we want the end point. So we're going to change just a bunch of this stuff. Might be called ending point, but we'll see what happens when I try and compile it.
I feel like it's swapped somewhere.
Sorry?
Like the numbers, one of them is swapped.
You're right. So this should be 1, 2. Yeah. Oh. Sorry, I'm not used to this laptop. Yeah, you're right. Because it should be row 1 and column 2. Yeah, perfect. Thank you. So if we DCC that again, yep, this should be called ending point. I could have checked the enum, but I decided to go for it, see what would happen. Or maybe it's not. What is it called? Sorry, called path end and path start. Yeah, so make sure you also double check those. Sorry, I definitely should have done that before. So path start and path end, like so. So if you compile it, now it works. We're basically just saying at row 1, column 2, we want it to be path start, and at row 4, column 10, we want it to be path end. So it should represent this image that we have over here. That's the idea. And yeah, there we go, cool. So we have the S there and the E there. And that's just like manually doing this. In the assignment, because we're scanning in the start point and the end point, you will need to worry about, rather than just like hard coding variables in here, so like 1, 2, 4, 10, you will need to scan into those variables and then use those to access the 2D array. So it gets more complicated with stage 1.1, but something similar to this will definitely get you past. Cool. We had a bunch of information, some hints, and all that kind of stuff. And then in stage 1.1, also make sure you just print out the map afterwards. This is just a way for you to check that it actually works. So that's what we've done here. But yeah, so that's stage 1.1. Once you get that done, you should be good to go on to future ones. I think just starting out an assignment can be the hardest part, but as you get into the flow, it gets better. Yep.
Is there a way to execute the different stages of the code separately? Say, for example, I want to run just stage 1 or just stage 2. Is there a way to do that?
Yeah, so the question was, is there a way to separate stages out to test them, I guess? So the assignment, all the stages build on top of each other. So technically, like everything in stage 2 would always come after all the input for stage 1, but it is still one program. However, what you'll notice actually is that you can run auto tests for just like stage 1.3 in this example. So you can run them for different parts for sure. Yeah. So you don't have to like run one auto test that does like 50 tests every single time. Yeah. Cool. Yeah, and once again, like you can test stage 1.1 just by doing this. Every single substage will have its own test that you can go through. All right, stage 1.2, initial enemies. This is basically just testing that you can also access the entity component of somewhere on the map. So it's basically saying you enter how many enemies should be at the start point to begin with, and then you just set that. So in this example, it's usually good to just look at the examples for these. It makes a lot of sense. We do all the stuff from stage 1.1 here, and then we move on, and stage 2.2 starts here. So we say, okay, I want 14 enemies initially here. And if you see, we print out the map afterwards, we've now got 14 at the starting tile. To actually go ahead and set the number of enemies at a tile, there's actually two things you need to do. I think it is mentioned in the spec. Yeah, it is. So to actually create an enemy at a tile, you need to first put the enemy entity on that tile. So change it from empty to enemy. And then you also need to update the number of enemies at that tile. So like, for example, if we just, actually we'll keep that in. Let's say, because we're gonna put it at the start, right? We're gonna say map12.entity equals enemy. And then you also need to go ahead and say map12.entity, or not entity, dot enemies equals something like 5, basically. So we're saying there is going to be an enemy at the starting tile, but there's going to be 5 of them, essentially. So if we compile that again, and we run it, now we see there's a 5 there. So printing out the map will handle all the like enemy stuff. You don't need to worry about that. As long as you update the map correctly, it should be all right. But yeah, obviously you can't just put 1, 2 here. You'll need to actually work out what you need to put in those indexes or indices. Yeah. So moving on from that, stage 1.3 is where it kind of goes up a little bit. So because we're using 2D arrays, we're going to be testing you on actually being able to loop over 2 dimensions in the array. So for stage 1.3, which follows on from 1.2, you will be implementing a way to draw a lake, basically. So this is how the command works. You provide a row and a column. So this is where it like starts. This will be the top left of the lake. Then you provide the height and the width, which would be how far it stretches downwards and how far it stretches to the right. So for example, enter lake 1, 2, 4, 6. You'll see that at position 1, 2, that's where the lake starts. And then you'll see that the height, that almost dropped. The height is 4, so it goes down 4 positions, and the width is 6, so it goes across 6 positions. So that should hopefully make enough sense. It'll just be working out how to implement that. That is the hardest part. And for this 1.3, you also have to do a little bit of error handling. So obviously there's going to be a problem here if you put the starting point, so like the row and the column, outside of the map, or it was going to like stretch outside of the map. For example, if we had 6 stretching downwards, then the lake would kind of stretch off the map, right? Which we can't really change our 2D array to modify that. So if something like that is going to happen, you just want to print out an error saying error, lake is out of bounds, ignoring. That's all. So in each stage, if there's any errors you need to handle, they'll be under this header here, error handling, and it'll just tell you in what cases you need to do certain things. Yeah.
So if it doesn't have an error handling like section, then we don't need to do error checking for that stage, or do we need to do that for every stage?
We will pretty much tell you whenever there's errors you need to handle. So there's 2 main parts to the assignment with that kind of question. So error handling will tell you if there's anything that could be bad input from the user, you should print something out. And then we also provide assumptions for each stage that says like, okay, the given lake will never overlap with the starting or ending points. So you don't need to worry about if the lake was going to stretch over the starting point or the ending point. So this should pretty much go over every case that you need to worry about. If it's not mentioned and you're concerned about it, feel free to ask on the forum. We can pretty much handle everything. But in most cases, if it's not mentioned, that means that you probably still need to handle it in some kind of way. Yeah. But forum is also the best place if you're just unsure. Yeah. And then once again, there's also examples here. So like this is stage 1.1 again, stage 1.2, and then finally stage 1.3. So in this example, we say 2, 2, 3, 6. So this is at position row 2, column 2, and it stretches down 3 rows, right? And it stretches across 6 rows as well. And then maybe, for example, the lake is out of bounds, like we provide -1, 1, 1, 1. The -1 would obviously be out of bounds of the array because we start arrays at 0. So as a result, just print out this error and then you do nothing to the map. Cool. And that's all of stage 1. So being able to finish that is probably the main goal you should have for now. But there's only 3 parts to it. You can kind of think of them as 3 mini labs, one after each other. But yeah. So does anyone here have any questions about stage 1? No? Awesome. Is there anything in chat?
Not yet, but it also hasn't got up to you asking if there's any questions.
That's fair.
If there is, I'll
Yeah,
chime in.
of course. Okay.
Is there a certain amount of time you should aim to spend on stage 1?
Yes. So I would recommend starting stage 1 this week. Everything, all the content for it should have been covered up to Monday lecture this week. I believe that was 2D arrays. Yep. So I would aim to try, at least attempt stage 1 this week, because it kind of gets you to understand how hard it's going to be and how much time you need to put into it. But obviously, like you can, yeah, sorry, I'm just thinking. Yeah, I would say try it this week. If you have issues, come to the labs, like come to your lab, ask your tutor about things. Go on the forum, ask questions. We will have people on the forum specifically for assignment questions. So that's useful if you get stuck. Don't just suffer in silence, basically. Ask for help when you need it. Doing your first big assignment for a comp project can be pretty daunting the first time around, for sure. So no one's going to judge you if you have issues and you need help. But I would aim to finish stage 1 by the end of this week, but obviously you have other subjects that can run into issues there. I would say aim for it at least by Friday next week then as a result. But obviously it depends on who you are, how much you want to get done. Just finishing stage 1 is pretty good for the course. That would be considered about a pass, right?
I think 35-ish.
30, yeah, sorry. Yeah, so that'd be 35% for the performance mark, I believe. Yeah, cool. And they should have all the weightings down the bottom here somewhere.
So stage 1, stage 2 is enough for a sort of credit.
Yep. And then also in this assignment, we mark you on style. So even if you can only finish stage 1, but you have really, really good style, you could get an extra 20% just off that. So make sure you guys follow the style guide for this assignment, run the 1511 style command for the assignment and just always be passing it. But yeah, like a big chunk of the assignment will be on style itself. Cool. And also we'll be running extra help sessions over the coming weeks. So you can get a one-on-one with a tutor basically to just ask questions about the assignment. So make sure to go to those as well if you're struggling. But yeah, we have a lot of options for you guys. You can also email tutors and see if you can come to their labs. They can say yes or no based off that. But yeah, just ask for help if you need it basically. Cool. So stage 2, this is where it starts getting a bit more complicated. So stage 2, basically, it starts off with you actually going and creating the path on the map. So currently we've got the starting point and the ending point, great. But we kind of need a way to connect the two, right? So how we do that is we actually allow the user to create a path. So in this example here, basically 2.1 will say enter a path, and then you enter just a bunch of directions basically. So right, down, down, down. You can kind of see this, you start at the starting point, you go right, down, 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 and there you go, you've got that path there. So this is what stage 2.1 is. You can also go a bit crazy with the paths. So for example, right, up, right, down, all that kind of stuff. If you take the same start point here, then if you follow those directions, you'll go along this path and get to the end. So for stage 2.1, you'll be able to basically handle changing your map such that it looks like this. And just as a note, these arrows here are something that will be printed on your map. Basically, if you go up on the path, you should change the land of it to path up. If you go right, you should change the land of it to path right. If you go down, you change the land of it to path down. And then for path left, obviously the same thing. So just make sure as you take in these directions, you also modify the ground underneath whatever the current path is. This one will probably be one of the harder parts to get through, but we've provided a bunch of help. So we've got all these diagrams to help you out. We added some notes, some hints here, all that stuff. And we provided interactive for you guys just to kind of understand how you should implement it. So for example, we've got the starting point here, and you can basically click these arrows to start creating a path. And you'll notice that as you click the arrows, this path down here gets appended to, basically. So you can create random paths like this, and then this is the path you would be taking to actually go these directions. Cool, so we'll go all the way to the end. And there we go. So to go from the start point to the end point there, we have to take all these directions. So yeah, and you can play around with this as much as you want. You can fill up the entire map with just path tiles if you really wanted to. Perfectly fine. But yeah, the way you implement the path will probably be similar to how this interactive works. So it's basically you're at some direction. So you start at the start, maybe you move down, then you wait for the user to input the next direction, you move across, you wait for the user to input the next direction, you move again, and so on like that. So your code should probably be able to do a similar thing to this if you implement it in the way that we would expect in the course. But if you come with another solution, that's fine as well. Cool. And yeah, make sure for this exercise, you're going to be scanning in a bunch of %Cs, right? So there's always the problem with %C that if you're scanning in a bunch of characters, like literally D, RR, DD, RR, all that stuff, then if you put spaces between them, you have the issue where the space gets scanned in as an actual character in the scanf. So if you want to avoid that, so you don't want to take the space in as a direction, just change your scanf to this, and you should be good to go. So you just put a space at the start of the scanf, and that basically just says, ignore a space if it came before me, basically. But yeah. Cool. Once again, all the assumptions. So we're only ever going to give you these directions. You don't need to worry about invalid input. That's fine. Yeah, just read through all of these. A lot of the assumptions make things a lot easier. So like the given path will always reach the endpoint, and the path can never go back on itself. So you don't have to worry about the path like turning back into itself or anything. That will never happen. Yeah, but I recommend to go through these examples as well. I can even show them just, this was stage 1.3, and then we're moving on from that to the next part, stage 2.1. And you see we've also got the arrows here as well. Cool. Okay, stage 2.2. So this is where we start going into another idea, basically. So you guys would have learnt by now, I believe, being able to basically run scanf in a loop to scan in like any number of things, so like a variable number of things. So in this stage, we're basically going to be going over a command loop, which lets you scan in any number of commands followed by some other input, and then based off of that, a different part of your program will run. So for example, in stage 2.2, we're going to allow the ability to just spawn enemies at the starting point. So in stage 1.2, we did the same thing, right? We like, what's the initial enemies at the starting point? In stage 2.2, you'll be able to add as many as you want whenever you want, basically. So the command loop will consist of 4 parts. First, you need to prompt the user to enter a command. Then you scan in the command. Then you execute whatever code is relevant to it. So like in 2.2, if the command I think is E, then you're going to be adding enemies. But in later stages, the command could be like F if you want to be like flooding something. Yeah, so whatever's scanned in, that'll determine which part of your code should be executed. Then you go back to step 1, which basically just means you're looping through these 4 steps until the user presses Control-D. Cool, and we should have labs that go over very similar things to this command loop, so you can kind of just look at that code and base your code off of that. So don't worry if you're just starting out right here. We should have labs that will help you out a lot for this. Cool, a bunch of more hints as well. Make sure to read through those. One thing to note is that when you're doing a scanf in a loop, you always want to be able to stop when the user presses Control-D. So remember in a loop, or remember with scanf how you can actually check how many things are returned from it. So it's like how many things were successfully scanned in. That's what this will return. So for example, in this thing here, we have scanf, and there's 3 things we scan in. So if all of them got scanned in successfully, it's going to return 3. Literally, just if you write some code, you could say successful things scanned in. This is an awful name. Successful things scanned in. You would say like scanf %d, and then some input. So like we'll call it I1 and I2, so they stay on the screen. Yep, cool. So if I go to scan into integers and that happens all good, this will return 2, and I can actually use that return value to change what happens in my code. Now, when I press Control-D, scanf actually returns something else. You don't really need to worry about what it returns. It's basically just a negative value. But you should just check if the number of things scanned in was not what you were expecting, then just end the loop, basically. And that's how you would do scanf in a loop. But once again, it should have been taught in the lectures, so you can go back and look at those, and it'll be done in the labs as well. Cool. And yeah, a bunch of hints. Make sure to use functions in the assignment. If you don't use functions, you might lose a lot of marks for style. So they're really important just to separate your code out. But especially for this assignment and assignment 2, functions are probably some of the most important things that you need to make sure that you use. So yeah. Cool. If you want to have a look at how this all works, we'll go down this example. So stage 1.1, stage 1.2, stage 1.3, stage 2.1, that's the path. And then we get into this command loop. So it's saying enter command. I enter E5. That means I want to add 5 enemies to the starting point. So you see 5 gets added there. Then we're saying enter command again because we're like in this command loop. I say E3. So 3 enemies get added to the starting point. Now you've got 8 there. Then I say E10, and then 10 enemies get added. And then I press Control-D, and that will basically indicate to the program I don't want to be in the command loop anymore. And so it'll end, and you should print out game over, basically. So yeah, that's how that's meant to work. Any questions on that? No. Awesome. So stage 2.3, moving on from that, it's another command. So it's a T command now, and it takes in a row and a column. So the idea is that like we have all this stuff with the tower defense game. We can create our map, we can add a path to it, we can create enemies, but we also need to create towers, right? Because we want to be able to fight the enemies in some way. So 2.3 is just being able to place enemies on the map using the command loop that we just made. So T row column says I want to place a basic tower at the row and column provided. Cool. And what that kind of just indicates that I want to change the entity of whatever the tile is to be basic tower. We have all this error handling stuff. So this stage will have a lot of error handling. Basically, there's a lot of conditions to be able to place a tower. It might seem pretty simple, but there's actually a lot of things you need to worry about. First one is you need to have at least $200. So in stage 1.1, you actually scan in the amount of money someone has. If you don't have $200, you can't place a tower. Otherwise, you like place infinite towers, right? Towers can't be placed outside the map. They can only be placed on grass tiles. So they can't be placed on water. And they can only be placed on tiles where the entity is empty. So you can't place a tower on top of another tower, basically. Cool. So in that case, you just print out this error, basically. Otherwise, you print out this. Yep, so you can go through the examples for that as well, and that'll be fine. But that's stage 2. So moving on from that, stage 3 will be a lot of more stuff, basically. So I won't go too much into too much depth for stage 3, but basically you'll be able to actually move enemies along the path. So before you could just have them at the starting point, now you can move them along the path. 3.2, you can actually upgrade towers to different types. So different different towers can basically do different things. Like a basic tower can just attack around itself. A power tower can attack around itself, but with more power. And then a fortified tower can have more range and more power as well. All right. So after that, you also have stage 3.3. So actually attacking enemies. So attacking enemies pretty far into the assignment, even though it's like probably the most basic thing you would think of for tower defense. But that's because it's actually quite a complicated thing to do. So in the assignment, you have 3 types of towers. They all attack around them in a radius, basically. It's a square radius, as you can see in this picture here. And then each tower has a range. So a basic tower has a range of 1, which means you can attack left 1 tile, right 1 tile, up and down 1 tile, and then every other tile encapsulated in that square. Power towers are the same, but they can attack twice, basically. And then fortified towers would have this range instead. So 2 left, 2 right, 2 up, 2 down, and so on. And then obviously their power changes with which tower that they are. So we have a little interactive here as well. So you can place down a tower and it will show its radius. So basic tower is like that. Power tower is like this. And then a fortified tower is like this. And these numbers basically indicate that if you were to use the attack command, how many enemies would be destroyed at each tile. So around the basic tower, they're all 1. Around the power tower, they're all 2. And around the fortified tower, they're all 3, but they can overlap as well. So the power tower and the fortified tower overlap at all these positions, and so you could destroy 5 enemies at each of those tiles. And you can go crazy with it if you want. You could add a bunch of towers. It'll show all the numbers, but yeah, that's essentially how it works. Cool. So make sure you understand how that works, and you'll actually be going and implementing that. So you'll be able to add all the towers, you'll be able to upgrade them all, and then you actually allow the ability to destroy enemies that are on the tiles. So for example, let's say we go through one of these. So we go through all the commands. They usually get quite long because we have to do a bunch of stuff. But we've got all these towers here. So B is a basic tower, P is a power tower, and F is a fortified tower. We've got 30 enemies at the starting point. Now, if we attack once, then 3 enemies get destroyed. That's because the enemies are only in range of the basic tower and the power tower. And so if they both attack at the same time, the power tower does 1 damage, 2 damage, and the basic tower does 1 damage, so they do 3 altogether. So it becomes 27 there. And then we can move them along. So this M command is for moving. That's what was done in 3.1. It lets you move enemies along, basically, and then you can attack them again. This time, only the basic tower was in range of the enemies, so you can just attack them once, and it'll do 1 damage. But if you move them along again to the next part of the path, and then you attack again, the fortified tower is now in range, and so it actually does 3 damage to the enemies because that's what it does. That's how much damage it does. But yeah, that's basically attacking. That's going to be probably the hardest part of stage 3, just getting it all working, but it'll be pretty cool once you do. it'll actually let you create a tower defense game rather than just having a bunch of enemies that spawn and towers that spawn with not doing anything. But yeah, and then 3.4 allows raining onto the map. So we utilize water for lakes in stage 1. This one lets us utilize water a bit more. So you can kind of think of it as like an environmental event in the game where you just add water to the map given some kind of pattern. So you can basically specify the spacing between each water block. This is what will be given in the input. If I go back actually, this is the command. It's R and the row spacing, the column spacing, row offset, and column offset. And so if you change the row spacing, then it's basically saying that there is a distance of 3 between each water block in each row. So 1 to 4, there's a difference of 3. Column spacing, if you increase it, it increases the amount of distance between all the columns for each of the water blocks. You can also decrease it like that if you wanted, and then just fill out the entire map. But that'll pretty much ruin the entire game, I think. But yeah, so you can just add this event that does this. This row offset and column offset, really important to understand what this does. It basically just offsets every single water block by this amount. So if I say 2, everything gets shifted down by 1, like so. But the important thing to note is that it also wraps around up the top. So this water pattern isn't just on the map. It's also, you can think of it as like outside of the map, just like an infinite plane basically. And so if you have the pattern here where it's like every 3 blocks you want to have water, then obviously there's 1, 2, 3 here. And there's also a water block where the 7 is. It's just we can't see because it's not on the map. And so if I increase it again, now it's there, and you can also pull it down. This can also be a negative number if you want. That's perfectly fine, because it's just like offsetting it in the negative direction of the row rather than the positive direction. But yeah, you can mess around with this interactive. This one can be a bit hard, but just thinking of it like an infinite plane of a pattern basically could be the easiest way to understand it. But obviously, if you have questions, ask on the forum. We're happy to help out. And there's a lot of explanation of it if you want to go through that as well. And obviously, assumptions. Cool, so that's all of stage 3. Won't go into stage 4. There's basically 2 tasks for it. One is like being able to flood the map, so every water block will be able to like flood outwards. And the other one is creating teleporters on the path. So if you get to that, that one is pretty hard, I think. But it's exciting, so yeah. Cool, that's pretty much the whole assignment. Does anyone have any questions about it? And just like with every lab as well, if you want to give your assignment, you just do this command here. I recommend after doing like each sub-stage, just give it. So that way you always have like a backup if you need it. And then you can also auto test each stage if you want, and then you can auto test the whole thing if you want. That's fine. Cool. Any questions? No?
Nothing apart. Is there a stage 5? No, there is no stage 5.
There is no stage 5, no. So just go up to 4. You can do extra challenge things if you really want to, but we won't mark you on it, obviously. But yeah.
If we ask questions in flexible week, so do we do answer?
Yeah, so we'll still have people on the forum answering, for sure. And I think we still got help sessions running in Flex Week as well. Maybe I'll just go to the timetable.
We've got a bunch of help sessions.
Yeah. So help sessions. Yeah, so in week 6 we have like 20 help sessions, I think. So if you do need help, you can just come to one of those, for sure. Yep.
Where is the extra challenges?
Oh, so we don't actually have a page for it or anything, but if you want to just like implement random things like, I don't know, different kinds of towers that are more unique, and then you can go ahead and do that if you just want to show off to someone, that's perfectly fine. We'll happily have a look at it. Yeah, just don't submit it, because then like, obviously, it might fail against the auto test.
Where can I find the help session and how do we look for it?
Do you want to start, Ben?
Oh, yeah, I'll jump up and
Yep.
yell about some boring stuff.
Okay, hello everyone. So help sessions are running sort of, I think basically every day from now until the assignment's due. So you can get them by going just to the course homepage. Under this help sessions tab, there's a timetable. So we can see we've got a bunch starting yeah, sort of from this week, we've even got some on Saturdays. So if you want to, spice up your Saturday morning, head along to a help session. But yeah, no, we can see there's a bunch here. The face-to-face ones are fairly self-explanatory. They'll be in one of the labs around CSE. The online sessions will be held in Microsoft Teams. I believe you should have all been added to a Teams class for COMP1511 help sessions. So if you're having any trouble finding that, just make a post on the forum and we'll give you a nudge in the right direction. The other thing that I wanted to talk about quickly is just some of the sort of more boring stuff with the assignment. So in terms of due date, I believe you've already probably mentioned it, but it is due Monday of week 7. I believe we can find it down here. So yeah, Monday week 7 at 8 p.m. And there is quite a generous late penalty, I think. For every day past the due date you submit, we take 5% off the maximum mark you can receive. So for example, if you submit 2 days late, that's 10% off the maximum. So your highest mark you can get is 90%. But if you get 75% with that late submission, then your overall mark is unaffected. But unfortunately, after 5 days late, that's a 0%. So 5 days leeway, but after that, it drops down to 0. The other thing is that we will try and have I think this is incorrect. I think it's 20% now for assignment 1. We can check that in the course outline, but 20% for your overall mark. And as Rory mentioned, 80% for performance, 20% for your code style. So that's partially things like 1511 style, and partially things like your use of functions, your use of hash defines, making sure your variable names are sort of well considered and thought out. We will try and put up a more detailed criteria for the style marking on the spec, hopefully later today. But definitely at some point over the next week or so, we'll have a more detailed spec. So keep an eye out for that. It'll be sort of down here with the assessment scheme. And I guess, yeah, the sort of obligatory sort of, sad chat. Don't cheat. That's sort of, the summary of it. But yeah, we do run plagiarism checking on the assignments that are submitted. So when you're sort of chatting to friends, make sure you're not sharing any code with friends. It's absolutely fine to chat about general ideas and things you're struggling with in the assignment, but sort of just stop before that level of oh yeah, let me send you this function to have a look at, or let me send you my assignment, because we have seen it where someone will send their assignment and then the other person just submits it as is, which is not great. So, to end on a great note, don't do that, because that's never fun. I don't think there's anything else crazy I need to talk about. Yep, we've got help sessions, forums. Your tutes and labs are also a great place to ask for help. Additionally, as Roy also mentioned, if you feel like you need an extra hand, please let us know. Email cs1511 or Sasha directly, and we can also organise for you to attend some extra lab sessions if you need. Cool. Are there any questions about any of that? We're all fairly happy with the assignment. Are we excited for the assignment? No. Yeah. Got a single tear rolling down the cheek. Absolute silence. It's going to be great. You're going to love it. Anything else you want to add before we wrap up?
You don't need to finish the assignment as well. That's a big thing. We separate it out into stages so that you can kind of reach these milestones. And then if you reach and finish stage 3, that's fantastic. And you probably get a very high mark for that. So you don't need to finish things. It's not like a written essay. We're just going to mark you on the stuff that you did. We're not going to mark you down because you didn't finish stage 4, which is pretty hard anyways.
Yeah. So yeah, that's a really good point to reiterate. It's sort of, especially for a lot of you who will be coming straight from high school where, it's sort of if I got below 95, then that was awful. Very different world at uni. So, it'll take time to adjust to that, but yeah, stage 4 is really intended to be quite a challenge. Even stage 3 is quite difficult. I struggled with the, what was it? The rain.
The rain one? Yeah.
The rain one. Yeah, that one was fun. Thanks, Rory.
That's right.
So, they're intended to be challenging and to really make you think about it. So even finishing stage 2, stage 3 is a really good achievement. You should feel very happy with whatever you get done, especially in your first big programming assignment. So yeah, absolutely don't stress if you're not making up to things like stage 4. They are intended to be a real challenge. Cool.
Yep.
I think that's about it. We'll just check. Actually, would you mind checking my laptop if there's any question in chat? Just make sure we're not leaving the poor online. What do we got here? Floaty towers. Outline says 20%. Fraction of a stage. Yeah, so that's a really good question from online. If you partially complete a stage, you can still submit that and you'll receive any marks for the tests that pass as a result of that. So if you get, for example, halfway through stage 3, you complete stage 3.1 and 3.2, but you don't quite get up to 3.3 and 3.4, you can still submit that and you will receive those partial marks for the tests checking 3.1 and 3.2. So the only caveat there is that if you've done some work that breaks your earlier code, so for example, you try and implement 3.3, but it breaks scanning in the path, for example. Not sure how that would interact, but who knows? If it's breaking earlier things that you've implemented, then probably don't submit that because that will cause those earlier tests to fail. So just be careful with that. Again, if you're not sure about things like that, you can post on the forum and see, do we think this will cause problems with testing or it should be okay? A good way to sanity check that is just to run the auto tests for all of them. And if they're all passing, then happy days. If not, then go back and have a look as to why that might be. Cool. I think that's another. You submit stages. Do you submit stages together or separately is another good question. So the whole assignment is submitted just with one command. It's give CS1511 csdefense csdefense.c. You just submit your C file with whatever stage you're up to. But one thing to note is that just like with labs, you can submit multiple times. So as Rory mentioned earlier, a good way to do that is every time you finish maybe a stage or a sub-stage, just submit your code so that it's there's a backup, and if your computer gets wiped, you haven't lost your whole assignment, because again, that's happened before and it's very sad. So yeah, just submit regularly and you can resubmit as needed. Cool.
Can you resubmit?
Yep, yeah, you can resubmit. Cool. Any questions from in the room? Otherwise, I think we'll call it here. And of course, any other questions you have can be thrown on the forum, or you can ask your tutor or lab demo. Is that
a question? Sorry.
Does it work at safety and SW servers? Yes. So, do the forums give emotional support? We try, but we can't promise much. And yeah, so your work, if you're doing it, every time you give, a copy of your file is saved, so you can retrieve that from the student page. If you go to this submissions tab, a record of your submissions and your auto test can be found there. So if you ever need to grab an old copy of your code, that submissions tab will let you do that. Info from any other lectures before we can do the later stages? I believe not. I think, as far as I'm aware, you should be able to complete the entire assignment with the knowledge that we have as of the Monday lecture with two-dimensional arrays. Because basically, the key things we're covering are two-dimensional arrays, structs, enums, and then, code structures like looping, if-else, just things like that. So all of that should have been covered. It's just about getting more practice, getting more comfortable, and gradually building up those skills so that you can complete up to stage 4. Cool. Fantastic. So we will call it there. Thanks everyone for coming along. Of course, as always, any questions, check them on the course forum, and we'll be happy to answer them there. Okay. See you, everyone.
Thanks, guys.
Thank you.
End stream. Nah, you won't fail. I believe in you. You've got this.